throughout the presentation, and I will be saving them to ask the presenters at the end their answers to the questions. So first, I'd like to introduce our CEO here at TreePeople, Cindy Montañez.
Okay, good morning, everybody.
Cindy, I think your camera is flipped.
Oh.
We can see your
there. You guys
no,
are seeing my
if you click the we
is
can
that better?
see your, reverse your camera, and then maybe we can see, we just see a black square.
Oh, that's weird. Actually, the camera was on before. Let me try that again. Sorry, you guys. Yeah, the camera was on that direction. Okay, is that cool? Is that better?
We just see a seahorse, so maybe that's your opening. But go ahead, just introduce yourself. We'll figure it out.
Okay. Well, good morning, everybody. Again, I'm Cindy Montañez, CEO of TreePeople. Thank you for joining our conversation about the unequal impacts of public health that come from urban heat. As we continue to experience the hottest years on records, the deadly public health impact of extreme heat on people, especially the elderly and people of color, becomes more and more alarming. We've seen research that shows that if we all continue to set business as usual, communities throughout LA will face a doubling or tripling of extreme heat days. That means that in communities like my hometown of San Fernando, people can face 126 days of the year where it's 95 degrees or hotter. And we know that extreme heat kills more people than every other natural disaster combined. So we, as TreePeople, embarked on research with amazing partners, which you will hear from today, one of the greatest scientists that we've worked with. We've embarked on research to dive deeper into how much we would need to increase tree canopy coverage in communities in order to change the impacts of those oppressive weather conditions and possibly even delay heat impacts of climate change. As you will see in our research results, we modeled different scenarios to see what the public health impacts would be by increasing tree canopy coverage and reflectivity. What is strikingly clear to us is that millions of people are at risk of ending up in the hospital, or even worse, losing their lives during these extreme and oppressive weather conditions because of a collective failure to invest adequate resources in solutions like planting and caring for trees, which are proven cost-effective strategies to help cool communities. Over the last 2 to 3 years, TreePeople has more than tripled our investment to plant and care for trees in those communities suffering the most from extreme heat. Communities like San Fernando, South LA, Southeast Los Angeles, and the gateway communities along the I-5 freeway. We, with our partners and funders, have put in place resources to plant over 20,000 trees over the next 18 to 24 months in those communities. Unfortunately, while we are planting trees, trees are dying at a catastrophic rate across the region, and not enough trees are being planted and cared for to help cool communities. So you will see TreePeople dramatically increase our efforts to get significantly more private and public investment into urban forestry. Our collective response as a community to this public health emergency will literally determine a life or death outcome for our fellow Angelenos. And our actions will say a lot about how we rose up to the occasion to slow down the impacts of urban heat. So I just invite you to listen carefully to the details of our research results and think about how you can best contribute to these efforts to help save the lives of others.
Great. Thank you, Cindy, for that introduction. And now we'll move on to Edith de Guzman.
Good morning, everyone, and thank you for joining us. We are going to start with a poll. So let's see here. Oh, I guess it's already on. Wonderful. So I see that some people have already responded. It should still be active. So please go ahead and we'll take another 10 or so seconds for you all to answer this question of what weather-related cause do you think claims the most lives in the US during an average year? All right, so let's see. So you are already a very well-educated group. It's not a surprise that heat is in fact the answer. And in fact, in an average year, heat kills more people in the United States and in many other parts of the world than all other weather-related causes combined. You'll hear a lot more about this during our presentation today, so thank you for participating in that already. So these days, TreePeople is very focused on advancing equity and improving public health by prioritizing urban cooling solutions, but we did not always use this as a lens for our engagement. In fact, our work down this particular path started with a seemingly simple question. I say seemingly because this question is deceptively simple. What should our urban tree cover target be? This question refers to setting a target for what % of urban land, when viewed from above, should be covered by trees. In reality, though, there are many different ways of answering that question, many different lenses through which to answer that question. Should we prioritize, for example, improving air quality above other things using tree planting? Should we prioritize increasing wildlife habitat, capturing stormwater? While we plant trees for all of these reasons and more, we determined that any target should serve to improve public health first, and that in our warming climate, protecting against heat-related public health impacts is critical. So now we had a lens through which to tackle this question. And now it was time for us to look through that lens to see where it points and what we see through it. And this is where it points. The reality is that many Angelenos live in highly urbanized neighborhoods with a preponderance of heat-retaining surfaces like roads, buildings, parking lots, with limited vegetation to provide shade and evaporative cooling, and limited access to air-conditioned spaces. So how is it to be a resident in these spaces? Let me introduce you to my mother-in-law, Rosie. Rosie is an 83-year-old retired school teacher. She emigrated here from the Philippines and she never learned to drive. Here she is at a bus stop in her neighborhood of Koreatown. And as you can see, behind her and to the right there is the only tiny patch of shade in the picture, and a young man has beaten her to it. Here's another sort of expression of what it feels like to actually move through these spaces. We worked with a student team from the UCLA Environmental Science Department to characterize the pedestrian experience of heat in 3 LA neighborhoods. Here they are in the city of San Fernando, with a thermal image on the left and a regular photo on the right. On a 103-degree day in San Fernando, the surfaces at this bus stop reached 125 degrees for the bench and 140 degrees for the sidewalk. These surface temperatures translate into hotter ambient and air temperatures, which in turn translates to conditions that can be very dangerous for more vulnerable populations, including the elderly, people with chronic medical conditions, outdoor workers, and the homeless. Where you live in LA, and wherever you live, even if you're not from LA, where you live impacts how much exposure you will have to heat and what amenities are available to you to deal with heat waves. Take a look at these 2 images. So how much green cover do you see on the left in South LA? On the right, on the other hand, Studio City in the San Fernando Valley, much more green cover available there. I wanted to share with you a little bit about how do these disparities emerge. And there's a recent study that I think is just wonderful. It really makes a wonderful contribution to this conversation. One contributing factor about why these disparities emerged is it seems to be really especially relevant to discuss as our nation engages in critical conversations around race and equity. So redlining, if you're not familiar with it, was a practice by the federal government that started in the 1930s that informed where banks and insurers would provide their services. This had the result of concentrating Black and other minority homeowners in certain neighborhoods because those neighborhoods were graded as undesirable and dangerous on a 4-grade scale. Redlining was banned under the Fair Housing Act in 1968, but its legacy has persisted through entrenched segregation, economic inequality, and a lack of public services to redlined communities, including trees. Let's take a look at what this recent study found. The researchers looked at 108 urban areas in the US to answer the question of whether historically redlined neighborhoods related to current patterns of heat distribution. They looked at factors including the amount of tree cover and how much of the land is covered by built and impervious surfaces. So let's look at what redlining looked like in Los Angeles. Green neighborhoods were considered to be the most desirable, red the least desirable. I was surprised to learn that I actually myself live in a formerly redlined neighborhood, the one on the very top left, just west of UCLA. But now that I know that, when I compare the streets around my neighborhood with those in blue or green neighborhoods in this general region, I see the difference. A little more about this. Here's the neighborhood description for my particular area, where redlined regions or neighborhoods were, quote, characterized by detrimental influences in a pronounced degree, under desirable population, or an infiltration of it. Lenders were advised to refuse to make loans in those areas. And you know, the language used was nothing short of egregious and comes straight out of a dystopian novel like 1984. For example, if you look at this enlargement of the area description, continued infiltration of subversive foreign elements. And this isn't the worst of it. There is even more egregious language as you dig into this. And by the way, you can dig into all of these types of documents through an interactive map created by the University of Richmond. So looking back at the study of the 108 cities in the US, here's what they found specifically. Essentially, limited real estate development translates into fewer environmental amenities that help to clean and cool the air, including urban tree canopy. You can see that in the Western US on the bottom left, green-lined neighborhoods today, this is today, have 2 to 3 times as much tree cover as red-lined neighborhoods. This is 50 years after redlining was deemed illegal. In terms of temperature, 94% of cities studied showed patterns of elevated land surface temperatures in historically redlined neighborhoods. And the differences between redlined and non-redlined neighborhoods on average were nearly 5 degrees Fahrenheit and up to almost 13 degrees Fahrenheit. So even today we're seeing this. So now that you know a little about the sort of the context about the issue and some of the reasons why it persists, let's talk solutions. Through conversations that Dr. Kalkstein and I started about 5 years ago, we determined that we could explore the potential of reducing urban heat through trees and reflective surfaces, highly reflective surfaces. We founded the Los Angeles Urban Cooling Collaborative, which we are proud to say has representation from not only academia, but nonprofit organizations, local government, and communities. And it's really a national collaborative, even though we call it the Los Angeles Urban Cooling Collaborative. We have partners in all parts of the US. And in fact, Larry today is joining us from Florida. We received very generous funding from the USDA Forest Service and Harvard Westlake School, which enabled us to tackle the study that you'll hear about today. Dr. Kalkstein will provide much more detail about the study, but here's just a little preview to get you oriented, because this is admittedly fairly complicated stuff for some of us. I know it was for me the first time I looked at all of this. We tested several combinations of what we like to call prescriptions of tree cover and solar reflectance, which is also known as albedo. So you'll see that term in the presentation here and there. And we tested that for roofs and for pavements specifically. We tested combinations of these with low, moderate, and high numbers. So for example, one prescription would have high solar reflectance and low tree cover, and so on. We tested these against current baseline conditions, both for the county as a whole and on heat vulnerable districts within the county. We also ran some novel climate projections to see if adopting these prescriptions, as Cindy mentioned, would delay our region becoming hotter. And here in a nutshell is what we found. We found that temperature reductions could be extremely meaningful, between about almost 2 degrees Fahrenheit and almost 4 degrees Fahrenheit, which sounds maybe somewhat small, but it's actually, this makes a life or death difference for some, especially the most vulnerable among our communities. In terms of numbers of lives saved, upwards of 25% of lives currently lost to extreme heat could be saved during the worst heat waves, saving dozens of lives per heat wave, potentially, even more potentially if we have extremely oppressive ones. We also found that actual weather situations could be shifted, and Dr. Kalkstein will cover this a bit more, but this was a surprise. This is not something that, that we often see with this kind of work. And finally, we found that heat impacts of climate change could be delayed from about 25 to 65 years, depending on the emissions scenario that we looked at. So that's what I had to share with you. I hope that you find the rest of the presentation as interesting as I think all of us have during the course of this work over the last couple of years. And now I'll turn it over to Dr. Kalkstein. Larry, I think you're still muted.
Okay, can everyone hear me?
Yes.
Okay, thank you. Thank you very much, Edith. I'm proud to be part of this collaborative. It's unique because of the different types of scientists, social, physical scientists, and professionals who've been involved in it. And it's been really a lot of fun to work on this particular issue in terms of trying to understand how changing the albedo and tree canopy can really help change the whole meteorology of an urban area and also save lives. Next slide, Edith. So poll number 2, which I am not seeing on my screen at this point, but I think we can just summarize it. There we go.
Yeah, so we'll just give folks maybe
Yes.
20 or 30 seconds to answer this. What weather-related factor do you think is most important to determining a region's vulnerability to heat? Just give you a few more seconds here. Results are coming in nicely. Five more seconds. All right.
Okay, well, it was close, as you could see, and I would have thought that answer number 1, how hot the region gets, would have been the winner in the past, but it actually is not. Many less people die of the heat in hot, humid places than they do in places that have high variability in the weather. So think of Los Angeles for a second. In the summer, most of your days, if you live in Los Angeles proper, in the 80s or 70s, and then a Santa Ana moves in, and you suddenly have days that reach 100. So the proper answer, and we'll talk a little more about this later, is the variability of the weather. And I always tell my classes and my colleagues that more people die of the heat in Toronto than they do in Phoenix, Arizona. So this is one of the immediate interesting things that we have found from all of this. Okay, Edith, we might as well move on from the poll. So the first thing I want to do is to talk about quick facts involving heat and health. As Edith had mentioned, heat is the leading weather-related cause of death in the US by far. About 1,500 deaths per year on average in the US are attributed to heat, but it varies widely. If it's a cool year, there could be almost none. And if there's a hot year, there could be 5,000, 6,000, 7,000 deaths from heat, making it almost one of the leading causes of death, one of the top 10. So heat varies based on, obviously, the meteorology. Urban area residents are particularly sensitive to heat, partially because of the urban heat island that exists, making things even hotter, poorer living conditions, less space, and non-tropical areas, because they have the highest variability, are most important. The vulnerability of people varies among cities and neighborhoods. And as has been mentioned, it's usually the poorer segment of the population who lives in worse housing, has less green space, which is why TreePeople is such an important part of all of this. Those are the neighborhoods that suffer the most. And then the summer climate variability issue is more important than actual temperature. So take Singapore on the equator. More people die of Los Angeles of the heat by far than they do in Singapore. I live in South Florida. Almost no one dies of the heat down here. It's hot every day. Everyone is used to it. The urban structure is adapted to it. Our lives are adapted to it. So if you live in Toronto, for example, people are not used to the heat. Many less have air conditioning, and that causes a problem. Also, if the heat event is long, several days, that's a problem. People can get through one day and maybe 2 days of a heat wave, but once you get to 3 days or more, that's when the problems really occur. If overnight temperatures don't drop, they're almost as important, and maybe in some cases more important than daytime temperatures, because if you don't have air conditioning, you're waiting for relief at night. And on those hot, humid nights, if temperatures don't fall out of the 80s, that can be a real problem because indoor temperatures can stay in the 90s or higher. And most important, with present-day technology, we can improve the city's environment to lessen the negative health impact of heat. Next slide. So just to show you that this isn't a minor problem, this just happens to be Chicago's summer deaths for the periods of June through August, 1979 to 1995. So we just put together only the Junes and Augusts. That's all you're looking at here. And you could see that on average, about 3 people per 100,000 die of the heat in Chicago. And you can also see the heat waves. There was a big one in 83, a big one in 86, and a big one in 88. In those 3 years, and by the way, these are deaths from all causes, not just heat stroke or heat exhaustion, because people die of respiratory failure, heart attacks, strokes, many other things during the heat wave. And often that's not attributed to heat because the medical examiner doesn't know why someone died of a heart attack. And you can see what's gone on here. That little blip for 1983 goes from 3 to 5 per 100,000. You might say, well, that's not so much, but think about it. This is the whole Chicago metro area with 6 million people, and that's 60 100,000s. So if you go from 3 to 5, you're adding 2 per 100,000. You multiply that times 60, that little blip on the highest day is 120 extra deaths. And you can see those heat waves were about similar in terms of the number of deaths, but on one of those days, on each of those heat waves, we had up to 120 extra deaths. Now, of course, 1995 was the granddaddy of them all, and there have been books written by the Chicago heat wave of 95, where we got up in one of the days to 12 or 13 or 14 per 100,000. And let's just call that 13 just to make it easier. That's 10 per 100,000 above the baseline of 3. That one day, 600 people died of the heat in that one day. And of course, there were days around it. But heat is a silent killer. It doesn't do anything to the infrastructure, so people don't realize how bad it really was. And it's unlike a tornado or a hurricane where you see the places ripped apart. Therefore, people underestimate the impact of heat on human health. Next slide. The most vulnerable places in the earth are not along the equator, but are in the middle latitudes, in high population areas, and are in the developed world in general, not in the developing world. So this is one of those unusual situations where people in the more developed places of the world are having the greatest impact. Next slide. So let me just tell you the type of climatology we do. We call ourselves synoptic climatologists. Think of the word synopsis. We look at the entire weather situation as a whole, rather than just correlating heat or mortality with just temperature and humidity and cloud cover. We have typical weather situations that float over us. Think of giant bell jars of air, and then a cold front comes through, and another bell jar of air with similar, different properties comes in, and then gradually it changes to another one. So this is the way we look at things. Weather situations, of which there are maybe 10 or 12 different types in Los Angeles in the summer, but there are really only two that we are interested in. One is called the dry tropical, which represents this DT air mass, represents the hottest and driest conditions of any location. They are the Santa Ana conditions, where air comes in from the east, transported from desert regions, and also it descends. As you know, the elevation on the eastern side of LA County are much higher than on the western side. As air descends, it rapidly heats by about 5.5 degrees per 1,000 feet. So the combination gives us a DT air mass on those days. Moist tropical plus is less common in Los Angeles, but common here in the east. These are days that hot, humid, we often call them a Bermuda high situation in the east. And these are conditions that also kill. They can affect people in Los Angeles because occasionally hot, humid air comes in, especially during the monsoon season. But this particular one is more important east of the Rockies than west of the Rockies. Next slide. So by evaluating the frequencies of these air masses and just looking at them rather than all days, we can really look at the impact of heat. We'll go to New York first. The 11% is the percent of days that are either DT or MT plus. And on the average DT day, the mortality is 16.6 above the baseline, above what you might expect. So almost 17 people die on average on a DT day. That's a 7% increase in mortality. You can see New York responds similarly to both air masses. They're about the same. So we're looking here and seeing that on average, and if you have 11% of the summer days are this, 17 people die of the heat on 11% of the summer days. You could do the math yourself to see that the average number of deaths from heat in New York is well in the hundreds in each year, but it's not the same. It varies. Some days are very high, some days are very low, even in these air masses, especially, let's say you have 3 straight days of dry tropical. That's going to kill much more than the first day of dry tropical. So this is just a mean. Even Seattle has problems. At an MT plus condition, 10% increase in mortality. The places that have much less of a problem are Phoenix and New Orleans. Every day is MT plus in New Orleans, so we had to dig to MT plus plus plus, get the most extreme days, and even then only 2% of the days killed anyone. In Phoenix, only 1% of the days do. Phoenix people know how to deal with the heat. What happens is that in Europe, we have real problems because there's less green space. That's why 35,000 people died in 2003 during a terrible heat wave. And look at the numbers in terms of percent for Rome. They're among the highest. Shanghai as well. Less air conditioning, very congested, same kind of thing. And there's the Toronto statistic, just so you can compare it with the other cities. Next slide. So what can we do with this synoptic climatology approach? One thing we've spent years doing is doing warning systems for cities. So whenever you hear an excessive heat warning has been called for Los Angeles, our system is actually in use in Oxnard, California, where your weather service station is, and they use it for guidance to determine when to call a heat warning. We can actually estimate the number of heat-related deaths more accurately than the medical examiners using that approach that you saw with the Chicago graph, where you see those numbers spike like they did. We can break these data down into neighborhoods, into smaller demographic units, which is one of the things we did with LAUCC and Edith and I were part of. We can estimate the impact of climate change on deaths because we have models that estimate what the climate's going to be like 100 years from now. Their accuracy is sometimes suspect, but at least we could come up with some models and estimates of what's going to happen. And most important for everyone, we can estimate how cool cities' technologies can reduce heat-related deaths. By cool cities technologies, we mean increasing the reflectivity of roofs, of pavement, and also by adding tree canopy in greater amounts to the different environments. Next slide. So how can we cool our cities? Let's go into specifics, and we'll go to the next slide and show you some examples. Well, of course, urban greening is very, very important. Many of you understand that because you're members of TreePeople. And, you know, it's hotter in the inner city. That's the urban heat island. The denser the vegetation, the cooler it gets during a heat event. It's still hot in the suburban areas or in the rural areas, but it's much less hot than it is in the city. So shade provided by trees, along with the fact that they evapotranspire and they do other things which cool the city, are very, very important. Next slide. The other thing I've been working on a lot is with the 3M Corporation and other corporations that make material that goes into the roofs of houses that can reflect more solar radiation back into space. They are actually heat-reducing granules that are mixed in with the shingle material, and they can quadruple the albedo of the roof. That means the roof, instead of reflecting maybe 7% of the energy, can reflect 28%. What does that do? It lessens the amount of air conditioning use because the inside of the house stays cooler. It takes energy that would have been absorbed in the surface and it reflects it back into space, which means that less is absorbed. It improves air quality because many pollutants are formed more rapidly under hotter conditions. So if you cool the conditions, they are formed less rapidly and you have a more pleasant general environment. Next slide. So in our analysis that we did under this Forest Service grant, we had a countywide analysis which looked at the entire county and assumed similar prescriptions or similar scenarios for all. The advantage was that we had a large size for mortality. About 150 people die a day in Los Angeles County on average. And so we had a large number of deaths to look at. That makes it easier statistically when that happens. The disadvantage is that we couldn't break the results down locally, so we don't know how one neighborhood differed from the other neighborhood in response, which led us to this district level evaluation. We used social scientists from Cal State Northridge who did a great job in dividing LA County into homogeneous districts that we could determine socially how different groups, different levels of economies and so on respond. The advantage is knowing the impact of socioeconomic factors on heat-related mortality and quantifying it, which is one of the first times this has ever been done. The disadvantage is if you break the district or neighborhood down too small, there are too few deaths for us to work with, and we usually need larger ones to make our statistical relationships more significant. But we tried to develop areas that had about a 300,000 population minimum for each of these districts that we developed for LA. Next slide. Then we evaluated 4 different heat waves to see how people reacted without any of the benefits of Cool City Solutions, and then how they reacted using the scenarios or prescriptions that I will show you shortly. The 4 heat waves are listed. Doesn't matter that you know the dates. It just matters that we use different kinds of heat waves. Not all heat waves are the same. The July 22nd to 2606 heat wave had all MT plus days. The one in 08 had a mixture of days. We wanted to look at one less extreme heat wave that wasn't quite as bad as most of the others. And then we took one very hot, dry Santa Ana heat wave. And as you probably know, most of the Santa Ana conditions occur late in the summer and sometimes even in early fall. Next slide. So here are the scenarios or prescriptions, as you could see. The basic control was that we assumed that in LA we had a 16.6% canopy cover, 10% of the energy is reflected from the pavement, and 17% from the roof. We changed it, and you can see first one is low canopy, high albedo. We increased the canopy cover only to 20%, didn't change it much, but we increased the albedo by a large amount. But we wanted it to be realistic, so we assumed that we can increase the albedo to 45% roof. Then we had a high canopy, low albedo, number 2, moderate for each, and then the pie in the sky, which is the prescription 4, where it was high for everything. Next slide. So we actually had a modeler, a gentleman named Dr. David Saylor from Arizona State, who I work with a lot. And he is able to model the entire district of LA by putting it into those little dots that you see. And what we have here is the 2-meter air temperature difference for the heat wave of August 26th for 3 different times, morning, midday, and evening, as you go from left to right. The bluer the color, the more cooling you have. And you could see, according to his prescription, in the midday, the bluest is darkest. And we did have the best results for midday, where we got decreases of 1 to 2 degrees centigrade, which is something like 2 to 3.5 degrees Fahrenheit. Also, those arrows represent wind, so we were able to determine the impact of wind flow on all of this as well. So you can see we can actually quantify the cooling using the cool scenarios. And again, this is for prescription 1, the low tree cover, the high reflectance scenario that I just showed you before. We did this for every one of the different scenarios. We used all the scenarios for all the days of the heat waves. Next slide. So here's the kind of result we get. And I know this looks a little overwhelming, but let me see if I could break it down for you. On the far left, this happens to be the September 2010 heat wave, the dry tropical Santa Ana heat wave. And you can see it has 5 a.m. apparent temperature, which is how the temperature feels to us, and the mean apparent temperature for the day, and then mortality increase. Also, it has the air mass type, DT. So look at the baseline, look vertically down, and the baseline, it was all DT, except for the last day. They were all DT days. You could see the mortality increase for each day. That 5% in the furthest upper left box on this 26th means that we had a estimated 5% increase in mortality because of weather conditions on that day. Remember, I told you there are about 150 deaths in LA a day. So that's about 7 extra deaths. For the whole heat wave, it summed up to 12.4% increase. The bottom left number in the yellow, that means 12.4% of 150 is about, now it's more than 150 because each day is 150. So it's 12.4 of 600. Sorry about that error there. That means that that heat wave we estimated caused 74 extra deaths. So one single heat wave in LA, 74 extra deaths, according to our modeling, based on how LA responded historically to all of this. Then we have the cases, 1, 2, 3, and 4, this prescriptions. Remember, 4 is the pie in the sky. Notice that in day 1, we changed that DT air mass to a dry, moderate DM air mass, which doesn't kill anyone. You'll notice that instead of 5.0, we have zeros for the mortality increase on that first day. And then we didn't change the air masses on the other day, but you could see that we decreased the percentage of increase in mortality. So we went, if you go down to the mean 4-day increase, we went from 12.4 for case 1, 10.5, case 2, 9.7, case 3, 9.5, and then the pie in the sky, 8.8 increase. So an 8.8 increase, 8.8 of 600 is 52 deaths. We actually reduced the number of deaths by 22, from 74 to 52. That is a 29% increase in decrease in mortality using scenario 4. Let me say that again, a 29% decrease. That's what those 22 saved lives represent. Now, if we could save 22 lives in one heat wave, and think of all the heat waves you have, add those up during the period, and you can see how useful this can all be. Next slide. These were the people who did the district level evaluation, and so I want to give them some credit, but we'll move to the next slide because I want to show you the districts. These are the districts that we had. We actually had 18 of them, but we used less than that because we wanted to get districts that were poor and wealthy. They all basically met, not quite for some of them, the 300,000 population level. Some had some missing data. We got down to these 11 districts right here. You can see where the poorer and wealthier districts are, where the arrow is now in 18. That's a fairly low density district, a fairly wealthy district. If you go 5, 6, 10, and 11, go to number 1. Those are the high density districts, the poorest districts, and we hopefully would get the worst responses. I'm sorry to use the word hopefully, we expect to get the worst responses in those districts. Next slide. So here's an example of what we did. This is District 11. That was one of those poor districts that we had with high density population. This is the heat wave of July 2006. The temperature changes are at top, but I want you to look at the bottom. Remember again, we have the baseline, which is RX0, and the 4 different prescriptions, including the pie in the sky, RX4. We said that we had a sum of about 4.5 deaths. Of course, you can't have a half a death, but it's model data. So if you want to call it 5 deaths, you can. From this heat wave, under normal circumstances, we estimated 5 deaths. As we used our prescriptions, the numbers went down until ultimately for RX4, we're down to 2.73. For this one heat wave in this one district, we therefore estimate a 40% decrease because 2.73 is 40% less than 4.52. Note that we only changed these prescriptions for the district itself, District 11, not for all of Los Angeles like we did in the first case. We assumed that the rest of Los Angeles was exactly the same as it is today and just changed the district, which is a really unrealistically conservative way to do this. But we never want in science someone to say to us, well, you exaggerated the numbers. There is no way anyone can say we exaggerated the numbers because we just changed this one district. Next slide. So here's a case of the results from this on that particular heat wave. The darker, the greatest reduction that we had in mortality. And this is for high tree canopy. This is the pie in the sky. And I'm glad to see that we're not glad to see people die. I'm just glad to see that statistically the responses were intuitive in some of these cases. 5, 6, and 11 were bad. 16 was pretty bad, not because it was poor, because it was a very hot district in the valley. And the districts that were well off usually came out better, like 18. There was one big shock to us, District 10. And for whatever reason, District 10 did not respond to heat the way we expected. You see, we have no declines there in terms of using these cool cities technologies that we have in prescription 4. And right now we're in the midst of trying to understand what is going on in District 10 that allowed us to have a good response in 5, 6, and 11, but not in 10. So that's one of the open questions we have in our results. Next slide. Here's another case. Everything was pretty consistent. 1, 5, 6, and 10 high. 1, 5, 6, and 11 high, and 16 high, the hot district. 18 low, 10 is a mystery. Next slide. So the last thing I want to talk to you about is, can we now estimate how many years we can delay climate change? We estimated that with prescription 1 for Los Angeles County, the mean reduction in temperature of maximum temperature in LA County was 1.1 degree, 1.0 for prescription 2 and 3, and 1.7, of course, not surprisingly, that's like 3 degrees Fahrenheit for number 4. Now, what we did is we looked at the climate models that predict weather into the future, the ones that are used for climate change analysis. The RCP 8.5 is the one used by the UN. It's called a business as usual emissions scenario. That assumes that we're going to do everything in the future as we're doing today. If we do that, what those bars show, the 28, the 25, the 25, and the 43, is how many decades we are going to delay climate change. Now, let's just take the 43 for the RX4. According to that business as usual model, it will take 43 years to increase the temperature 1.7 degrees from what it is today. Well, that would perfectly match the reduction of 1.7 that we expect. So if it warms 1.7 degrees in 43 years, and we have reduced by using these cool city solution, the temperatures by 1.7 degrees, we will have delayed climate change by 4 decades. Now, if you use moderate mitigation, this RCP 4.5, that is assuming that we put into place some sort of pollution controls or emission controls. Since it's going to warm at a lesser rate if you do that, you'll notice that the decades of delay are even greater than they are if we don't do anything. So one of the arguments we're making here is that we can delay climate change significantly. And that is a very important factor. If we can delay climate change by 40 or 50 years, maybe we can come up with an answer to solve the whole climate change problem in that 40 to 50 year period. Next slide. So let's just summarize quickly. In general, but not always, lower income, more densely populated districts demonstrated the greatest increases in heat-related mortality. Thus, they showed the greatest benefits from the use of cool city solutions. There were some unexplained exceptions, especially District 10. The wealthier but hot District 16 showed great impact. And the use of cool solutions can delay climate change by at least several decades in Los Angeles. Next slide. We cannot underestimate the impact of heat on human health. We need to keep gaining a regionality and some input on the regionality of the problem. I'm glad to tell you now that we are starting work with the city of Minneapolis, the city of Madison, Milwaukee, the city of Miami-Dade and Broward counties, cities in there, to determine the same kind of thing that we've done with LAUCC. One of the things I like about this is that in today's political climate, there's a lot of skeptics who think about climate change as not being a disaster. I won't even get into that. Doing this research, we can see that heat is already the largest weather-related killer, and we can today, with present technology, reduce mortality significantly. So whether you're a climate change denier, skeptic, or advocate, it doesn't matter. No one, even the greatest skeptic, cannot deny the benefits of these cool city solutions. And then finally, I love what Edith and I were able to do to get this whole group of people to form LAUCC, nonprofits, academic, private sector, government. We tackled it together because we all have our strengths and weaknesses, and we used each other's strengths to work this out. And I believe that's the last slide. Thank you.
Thank you, Larry. So before I turn it back over to Ariel, I just wanted to direct you all to treepeople.org/urban cooling, where you can learn lots more about this. We have a project report as well as a project infographic and some videos from past webinars. So we encourage you all to look at that when you have a chance. And now I'll hand it over to Ariel.
Great. So I've got a lot of questions for you, Dr. Kalkstein, from our great audience here. And thank you for the wonderful presentation, Cindy, Edith, and Larry. It's really great to know that trees save lives. And I think that's a big part of what we care about here at Tree People, along with other cooling solutions. So the first question I have for you is, for the data on the deaths for heat, what is the data dependent on? Is it based on how doctors and coroners document the reason for death?
That's a very good question. Not at all. It's based on total deaths. Everything is included in those data. So it includes anyone who died from any cause, because we have found that all-cause deaths are the best way of doing this. Now, clearly, when you do all-cause deaths, there are some deaths that are not related to the weather, but I'd rather have them included than exclude ones that might be. You know, for example, heart attacks, strokes, and respiratory failure are so important. How about accidents, car accidents? Is it possible that more people are stressed during hot weather? Should we remove accidents or keep it in there? Someone who has been weakened greatly by a terminal disease, maybe they did die because the heat was the thing that kicked them over the edge. So we use all-cause mortality.
Got it. Thank you for that answer. Another question, are the areas with Mediterranean climates around the world more vulnerable? That's what it looked like on that global map that you shared.
They are among the more vulnerable areas. So any place like LA, again, going from Spain across through Italy, down across Lebanon, Israel, and northern Egypt, and so on. What makes them vulnerable? Irregular, intense heat waves. All of those places are often comfortable, maybe not Cairo, Egypt, but a lot of the others. And if you have these hot situations occur, you have a problem. But it's not only them. We find that the northeastern US is very, very vulnerable. New York, Boston, Philadelphia, Midwest, Chicago, St. Louis, very vulnerable cities. They are all connected, they don't have the same climate, do they? They all have different climates. So they're all connected by the same thing. And that thing is that, in fact, they all have irregular and intense heat waves. And this is what keeps them problematic.
Got it. Okay, the next question is a question I can answer, actually. It says, how much water and how often should I water the tree in front of our house that just got planted in Commerce? This was a project that Tree People did. We're planting trees in Southeast LA, and we just finished up in Commerce. I'm excited to announce that next week we are going to be hosting at Learn at Home a volunteer week on how you can build a community tree care team, and it will really focus on how you can take care of trees on your street, what you need to do, who you need to mobilize. So it's kind of a virtual way of us helping folks through volunteering right now to take care of these trees throughout the summer, which is so important. That ties back to urban heat, because if the trees don't survive and create that shade and cooling, then we can't implement all these great solutions that you're talking about, Dr. Kalkstein. So please tune in next week. I can give you the pre-news that it's going to be Thursday. That session's going to be Thursday, next Thursday at 1 p.m. We'll send out an invite to all the folks on this call. All right, next question. Has there been any testing on using the reflective granules in asphalt or other road surfacing materials?
These granules won't work in asphalt. Nevertheless, there has been testing of using other type of materials in asphalt. I mean, you know, LA itself, as someone has noted, I see from the comments, LA itself has a program of whitening the streets and roads. And of course, white reflects energy much more than dark colors do. So the whitening of the roads is one way to do that. The 3M Corporation has discovered other materials that are also useful, especially for signs, painting of lines on roads, and so on. So there are ways, and there are different materials other than black asphalt that can also be used that are highly reflective. In Florida, many of our roads are covered with a white paving material. Of course, we're a hot, humid climate. The other thing is that there's a lot of testing going on which granules are best. There isn't only one kind of granule. We're doing an experiment near Miami right now where we have placed shingles with different types of granules on the roof, and we're trying to determine which of the granules create the lower temperature. We have grad students at the University of Miami doing this literally as we speak. So we are working on trying to find the most efficient granules. Now, let me just end by saying I'm not a chemist. If any of you asks, what are these granules and how are they composed? I'm a bioclimatologist, but I will be glad if someone is interested to put you in touch with people like my colleagues at 3M who can answer that question.
Great, great. Okay, next question. Can you estimate the cost of treating one district, say number 1, to the RX4 level of intervention?
Yeah, I cannot. Again, it's out of my realm of when we did these prescriptions, and Edith, maybe you can add to this. When we did this, we wanted them to be realistic. And so, yes, you would have to be pretty intense to get to prescription 4, but I guess it wasn't considered to be a break the bank type of situation. Let me just say that one way these things are funded is that people pay for the shingles, but they get tax benefits from the state or the federal government. So this is done with solar panels and around the country. There's no reason why if you invest $30,000, $40,000 in a roof with these materials, they will say that comes right off your gross income and we will give you a tax benefit. But I don't know the exact costs, and I'm sure Edith doesn't either, but you might have something to add if you'd like, Edith.
I do. So we actually have funding from Accelerating Climate Resilience Los Angeles, which is a new fund that we've been fortunate to receive some support through to actually answer that question. And so we are going to be working with a cohort of representatives from the city, of Los Angeles, from the county, and from other nonprofit organizations and even the U.S. Forest Service to look at how to realize some of the targets that have been set in documents such as the Green New Deal of the City of Los Angeles, as well as some of the county's own goals. We just embarked on this. We expect that we will start having some results in the coming months. And we are answering questions such as, what will it take for example, the city, which has a target of increasing tree canopy by 50% in its lowest canopied areas? What will that really take in terms of numbers of trees, as well as in terms of actually quantifying the costs and benefits of that? So look for probably a future one of these types of events when we're ready to share some of those results, but great question.
Yes, thank you for that question. Okay, is the data output from the model for all of the districts publicly available?
Yes, it's on the website. It's on my own website, and it's on, which is www.appliedclimatologists.com. And of course, it's on the TreePeople website.
Great. Yeah, that resource I think that Edith shared, and we can share that out after this as well. Okay, I have another question. Would it be safe to say that increased tree canopy had greater overall impacts than high albedo surfaces in decreasing the mortality rates?
Yeah,
What's the...
Yeah, which is more important? I don't think we can say either is more important. It depends on the type of heat wave. We saw results where the canopy was more important. We saw results where the reflective roofing was more important. Certainly the canopy helps reduce temperatures. And by the way, there's an aesthetically pleasing aspect to the canopy that whatever you put in your roof doesn't really give you. And I really do think that's a public health benefit when you have that. But I don't want to say that one outweighs the other. We have one minor disadvantage with increasing the canopy, and that is that it often increases relative humidity by a little bit, because then the trees are evapotranspiring more greatly. Nevertheless, when you look at heat indices, temperature is a much more of an important indicator than this little evapotranspiration gain. So we believe that tree canopy increase is one of the most important ways of cooling the city. And again, in present technology, one that is available to us, much like the roof technology. So let's just say they're equal if we're going to give it any term at all, okay?
Got it. Got it. I see a question here. How long will it take to complete the work and then see the temperature reduction if you implement RX4? I assume that's kind of part of what you were talking about, Edith, with the follow-up study that we're looking at.
Yeah, there's one more sort of distinction that you need to consider, though. If you implement reflective surfaces, those have immediate benefit. So you'll begin to see the benefits from that right away. Trees take time to mature. So, and they appreciate in value the longer they are around. So there is, an immediate benefit that you see, but the benefit actually increases as the trees mature. So the answer, it takes, a few years time for a tree to mature. It depends on the tree species. Some species are fast growing, some are not so fast growing. But we would expect that if we were to turn on the switch right away tomorrow, we would see some benefit, and we would see that benefit increasing over the next 5 or 10 years.
Got it. Okay, and then from one of our partners at LA County Parks and Rec, they're wondering if we're going to do more research in the District 10 community, since there seem to be some,
Yes, to that question, please don't abandon your work in District 10, okay? Because I see that your data makes me wonder whether our efforts will not be very effective, and I'm curious why. Keep working in District 10. It is a vulnerable district. Now, I will tell you, we're not sure why the results came out the way they did. The first thing we did was check the data that was given to us by UCLA and the med school there. Our experts there showed no problems with the data. So now when I gave this talk at TreePeople, I guess about 6 months ago now, there were 2 people from the city who approached me about dealing with District 10 specifically to understand about it. Now, remember, I'm not an Angelino, so I don't know the geography of District 10. So Edith and I are pursuing that with those people to try to understand what is going on with District 10. But something is wrong. I can't imagine there is no vulnerability in that district. Not all statistics comes out the way you expect it. There's always the chance that it came out randomly in a different way. If I were you, who working in that area in parks and recreation, please work with that area. Don't abandon it.
And let me just add, we suspect that there could be some social dynamics at work that we just weren't able to capture with the kind of modeling that we did. Dr. Kalkstein mentioned that the Chicago heat wave was one of the most studied heat waves in 1995. And there's a book by Eric Kleinenberg that looks at what happened. He calls it a social autopsy of disaster in Chicago. And one of his findings was that looking at demographics, looking at income, comparing largely Latino neighborhoods with largely African-American neighborhoods, the African-American neighborhoods suffered much more greatly. And the Latino neighborhoods appeared to be much more resilient. And he suspected that there was some social cohesion and just, you know, eyes on the street and people really sort of strong community ties within the Latino neighborhoods that that helped those communities actually fare much better. It could be that there's something like that at work here that we just have not identified yet. That particular district, District 10, includes communities such as Huntington Park, which are largely Latino neighborhoods. So we're really curious to see why that is, and we look forward to reporting back to you once we find out what it is.
Okay, I'm going to wrap up pretty soon here because we're over time, but I'll ask a couple more questions. Are there any suggestions that you have for the best tree species to plant?
I'll leave that to you, tree people experts. So
Yeah. My feeling about this is plant the tree that the various species that your community most resonates with. Any trees will actually be beneficial. And remember, urban heat is not the only benefit. Urban heat reduction or mitigation is not the only benefit you're going to get from trees. And if you connect with your tree because you love the way that it looks and blooms or whatever, that's extremely important. One thought, though, is that, occasionally we do get winter heat waves in Los Angeles. And actually, Larry has done some work with UCLA and others, identifying that we have the dubious distinction in Los Angeles to be the only region in North America that experiences heat-related mortality occasionally in the wintertime. So if you think about that, then planting trees that are deciduous, which means they lose their leaves generally once a year, might not be as protective as planting trees that are evergreen. So that's one consideration. The other consideration is, at TreePeople, we absolutely encourage you to plant the largest tree that the space will bear, the largest tree that is appropriate for a given space. And of course, that will give you additional benefit if you're able to do that.
Yeah, and I will say that if you, again, keep tuning into our Learn at Home, we're going to have more lessons on how to plant trees, what trees, especially in LA, given the climate specifically, and answer different questions like, I have this big of a space, what should I plant? So definitely keep tuning in for those. And I think the other questions I'm seeing really have to do with protecting already mature trees here in the city, which I can assure you that our policy and research team are very heavily involved with trying to advocate for that, and more urban forestry, more resources, more dollars going to that effort. So we will be also doing another Learn at Home about urban forestry policy at some point soon as well. So stay tuned. So I think that wraps up our question section. Again, thank you, Dr. Kalkstein, Edith, Cindy. Really have enjoyed this presentation. I wanted to make an announcement that we are hosting a volunteer summit on next Tuesday at 1 p.m. To sign up, go to that URL. We'll also be sending out an email about that. You can sign up for that newsletter at the URL at the bottom. And then we have that Thursday at 1 p.m. Learning how to build community tree care teams. We want to thank once more our sponsors, Subaru of Sherman Oaks. And you can follow us. We're doing a lot of new stuff on social media now, talking about this work. Follow us on Twitter, Facebook, Instagram at treepeople_org. And if you have specific questions, please go ahead and email us at learnathomewithtreepeople@treepeople.org. And we will funnel you to the right person, Dr. Kalkstein or Edith or other employees at TreePeople.
I'll be glad to give you my email if any of you have any questions. It's Larry K, LARRYK at Miami, miami.edu. And please feel free to email me, and as soon as I can, I'll be glad to send you an answer.
Great. And yes, this will be recorded. We will be posting this on our website, so you will be able to share it widely and rewatch it if that's what you would like to do. And yeah, we'd just like to thank you all again for coming and appreciate the presenters. And we hope you have a great rest of your Wednesday.